This is the Algebra 1 Unit 3B review. Question 1. Which graph represents the piecewise function? And so piecewise functions, the constraints are what determines our input values or our domain. So these are actually three functions that we're going to graph. We're going to graph f of x or y equals x, and that's going to be for x values that are greater than or equal to 2. So what does y equals x, what does that graph look like? Well, that graph looks like a diagonal line, right? We can see that our y-intercept is 0, right? Because it's saying plus, it doesn't say plus anything, so our y-intercept is 0, and our slope, the number in front of that, is an invisible 1. So our slope is 1, meaning we're going up 1 over 1. So our y-intercept is 0, and we're moving up 1 over 1. So we'll do a couple of those. We go down 1 over 1, going across this way, right? But then our constraint says if x values are greater than or equal to 2. So we're only wanting x values that are greater than or equal to 2. So let's go to the x-axis and we find 2 right here, right? So we just want x values, right? If we were to imagine this is separating our graph, there's x being 2 here. I'm just drawing a vertical line, right? And greater than that, we want everything on the right side of this. Okay, we also have the equal symbol, so that means that we're going to include when x is 2. Well, when x is 2, y is 2 here, so I'm making a closed circle to include that, and I don't want any of these other points that are less than 2, because again our constraint says we just want values of x that are greater than or equal to 2. So I'll erase the rest of this and continue a couple more points going this way, and we've got that portion of our graph. So now our next portion says f of x or y equals 3, right? So y equals 3. Well, what kind of line is that? That's a horizontal line, right, where all our y values are 3. That's y equals 3. But our constraint here says our inputs are just values where x is greater than negative 3 and less than 2. So negative 3 is right here, right? So we want to be greater than that, and less than 2. 2 is right there. So I'm going to erase everything that's not in that section. Okay, so rewriting this, we'd go from there to there. Okay, from negative 3 to 2. Now, at negative 3, we can look x values greater than negative 3. That doesn't have the equal symbol, so we're going to use an open circle here. And at 2, this doesn't have the equal symbol either. We want to be x values that are less than 2. Less than 2 would be to the left, so open circle here as well. So that's our next section. And then the last section, which is f of x equals negative x minus 1, so y equals negative x minus 1. So what's our y-intercept here? Would be negative 1. Right, and then our slope is also negative 1 right there, right? M, and our y-intercept B both happen to be negative 1. So negative 1 would mean down 1 over 1, right? Here, up 1 over 1. Like this. But then our constraint says that we just want x values that are less than or equal to -3. Well, where's -3? -3 is right there. So that means we want to be less than or equal to, meaning to the left, right? Here's -3. We just want to be to the left because we're less than or equal to. Now, because of the equal to symbol at -3, I want to put a closed circle here. And I just want the values to the left, so I'll continue my graph this way. And we don't want anything to the right, so we'll erase all those points to the right. And so that is what our piecewise function would look like. And we can see it looks like B, doesn't it? And it is B. Alright, so the same thing with this next one. I'm going to move just a little bit quicker when we do this. But here we go. So our next problem, same type of problem. We want our first part says f of x equals 1/2 x minus 1. So that's the same as y equals 1/2 x minus 1. And so what's our graph? Our y-intercept is -1. Our slope up 1 over 2. That's what 1/2 means, right? So up 1 over 2, up 1 over 2, up 1 over 2, up 1 over 2, down 1, left 2, right? And now we look at our constraint. Our constraint says we just want x values that are what? That are greater than or equal to 2. So here's 2 right here. We have the equal to symbol, so at 2, I'm going to put in my closed circle. Greater than is to the right, so going this direction, which means I don't want any of these points that are to the left, so we'll erase those. So that's the section of the graph that we want from this constraint. And then the last part, or the next part, is f of x equals 2, so that's y equals 2. Well, what kind of line is that? Again, that's a horizontal line, right, going across here. I'm just not, pretend that goes through. I'm going to erase it all here in a second, right? Because our constraint says that we just want x values that are what? That are less than 2. So here was 2 again, right? So we want everything to the left of that. So we're going to erase everything to the right of that. We were right here. We don't have the equal symbol, so I'm using an open circle, and everything to the left. We draw a line to the left. So that's that piecewise function. Alright. And what does that look like? That looks like B to me, right? Okay. Question 3. Taxi fare in Las Vegas is $3.30 plus 35 cents for every 1/7 of a mile or fraction thereof. Which graph shows the cost of a Las Vegas taxi ride of X miles? So we're going to start off with 330, right? That's our y-intercept. So that would be, we're going to start off at 330. And then for every 1/7 of a mile, we're going up 35 cents, right? So that means every 7/7 of a mile, what would that be? That would be 0.35 times 7. So for every 1 mile, we're getting an additional an additional 7 times 5 is 35. 721 plus 3 is 24. Right, so an additional $2.45 for every 1 mile. This should be going up $2.45. So 330. The next one would be what? $5.75. Should be at $1. And now what's happening? It's going up. It's going to go up. It's going to go up 0.35 for every seventh of a mile. So where would we be? That's gotta be this function. Why is it not these? Because these would be linear, right? This is a linear function, not a step function, and that would mean that we'd have increments other than every seventh of a mile. Same thing with this one. So here we're at, we'd start off at, well, the first one would be 330, and then for that first seventh in a mile should stay at 330, and then once we get to a seventh in a mile it should bump up. And this one's not quite right either, because it should be a little bit lower, just to be, to be careful. Or if it includes that first 35 cents in that first seventh of a mile, I guess that would be, you could include that, because that would be, what, 365, and that's what that looks like. So yeah, we could go with that. 4, what's the inverse? So here we're going to say x equals 10y minus 2. We'll add 2, x plus 2 equals 10y, divide by 10, and we get y equals, that's 1/10 x, plus, and 2 divided by 10 is 1/5. So 1/10 x plus 1/5. Y equals 1/10 x plus 1/5. And so it looks like we don't have the same answer. We've got 1/10 x minus 1/2. Well, we added 2 to both sides, and then dividing by 10 makes 1/5, not 1/2. And this one, if we distributed, wouldn't make what we have. So I'm going to say all these answers are wrong, and that's our correct answer. Same thing here. Let's do this one. This would be y equals, so f of x equals, x over 4 minus 5. That's the same as 1/4 x minus 5. So rewriting it, flip-flop x and y. 1/4 y minus 5. Same steps. We'll add 5. So we get x plus 5 equals 1/4 y. What's going to undo 1/4 times y? That's going to be multiplying by 4, right? So multiply by 4, and we get y equals, and we could leave this, that looks like the answer here, right? 4 times the quantity x plus 5. That's also 4x plus 20, right? And we could always rewrite it, y equals 4x plus 20, or f negative 1 of x, or the f inverse of x. So that's a correct answer. That's the same answer there. They mean the same thing. Uh, 7. Which function represents the inverse of the graph shown? Well, a couple different things we can do. Let's find this graph. This looks like our y-intercept, right? And so that would be the point. If that's -5, so -10, -15. So our b value is -15. And it looks like it's gonna be a little bit tricky to find our slope. So we're going from here, we're going to say one more to get to this section, so that would be up 1, 2, 3, 4, 5, so up 25 over 5, so that's the same as 5 over 1, so our slope is 5. So our equation would be y equals 5x minus 15, right? So then what would be the inverse of this would be x equals 5y minus 15, add 15, x plus 15 equals 5y, divide by 5, and that's y equals, that would be 1/5 x, and 15 divided by 5 would be 3. So 1/5 x plus 3. Right there. 8. Find the inverse. And these, we're just flip-flopping x and y. So instead of -1, 3, it should say 3, -1. And that would be this one. Let's do another one just to make sure. 1, 2 should be 2, 1. 2, 1. 3, 1 should be 1, 3. So it's that one. There's not a lot of work to be shown there. 9. Which inverse is a function? Select all that apply. So that was, if you remember, that was our horizontal line test. So if our inverse is a function, that means that we could do a horizontal line. We're only crossing at one point, so yes, that's a function. Cross at one point, yes, that's a function. Cross at 2 points here, so no, that's not a function. And cross it way more than 1, 2, 3 points there, so no, that's not a function. Evaluating the piecewise functions. So -7, f of -7. So our constraints here tell us where to go. And if we were to graph this, this is saying x values that are greater than or equal to -8 and less than 3. So, we'd have -8 and 3. We're greater than or equal to -8, so that would be a closed circle going this way, and less than -3. Alright, so that's open circle going this way. Our next one, we're between -3 and 2, right? So -3 and 2. We are greater than or equal to -3 and less than 2. And our last one, the constraint saying we're between 2 and 6. So between 2 and 6, we're greater than or equal to 2, closed circle going to the right, and less than 6, open circle going to the left. So now we need to find, well, where would 7, which graph would 7 fit into? Sorry, which graph would -7 fit into? So -7 would fit in, right here would be about -7, right? So that would be the top one. So what's our value then? -3. That's the point, -7, -3. That's the coordinate pair. -3, well, which one would we be at? Would we be at this top one, or would we be at the middle one? We'd be at the middle one because of the closed circle, because we won't wanting to be greater than or equal to -3. This one, the top one's just being less than -3. Well, -3 is equal to -3. So what's our answer? 4. 2. Same thing here. We go to the closed circle. That would be the bottom one. So 2 would be 2. And 1. Well, 1 is where? 1 would be between, it's less than 2. Right? 1 would be right here somewhere. Right? So that would be this middle one. So 1 would be 4 as well. 11 is going to be the exact same thing, except for now we'll need to substitute in these values of x in for x into the equations. So our constraint, this one's just talking about being less than 3, open circle going to the left, and our bottom one then is talking about being greater than or equal to 3. That would be a closed circle going to the right. So -8, that's less than 3. That would be this one. Alright, so we're going to substitute in this -8 in for x. So let me write it over here. We've got 3 halves. We're substituting in a -8 in for x minus 5. Alright, I'm substituting it in right here. -8 in for x. So, well, 2 and -8, right? So that becomes a -4 times 3 makes -12. Minus 5 makes -17. So this is -17 here. That's our work shown. Same thing on the next one. F of 0, well, 0 is less than 3 as well, so we do the same one. 3 halves times 0 this time, minus 5. That's 0 minus 5 is -5. So that's -5. 3 is equal to 3, right? So we'd use this bottom one. So we'd say, we're using this equation now, so 2 times 3 minus 3, 6 minus 3 equals 3. And 6, that's definitely greater than 3, so we use this bottom equation again. 2 times 6 minus 3, so 12 minus 3 makes 9. Uh, 12, graphing the piecewise functions. It's actually a step function here. So it's the same thing that we did at the very first problem here. Right, this first one says f of x equals 7, right? So that would be a horizontal line at 7, right? But our constraint says we just want x values that are what? That are less than -5. So I'm going to erase this. I just want x values that are less than -5. So that's right here. And I just want that portion of it. Less than -5 of the at 7. Because we don't have the equal sign, that's why I used an open circle here. Our next one is talking about f of x equaling 3. Alright, so that would be a graph that looks like this, right? Except for here we just want x values between -5 and -2. So from here to here is all we want of that graph. So we'll erase that, redraw it. So we're at 3, from -5 to -2. Now at -5 we've got the equal symbol, so we use a closed circle. And at -2 we don't have the equal symbol, so we're going to use an open circle. Next one, f of x equals -1. Same thing, that would be this, right? But now our constraint says that we just want x values from -2 to 4, so -2 to 4, so we just want that section of that graph. So we'll erase it, redo it from -2 to 4, just that section. And at -2 we have the equal symbol, so we're going to use a closed circle. And at 4 we don't have the equal symbol, so it's an open circle. And our last one, f of x equals -5, right? -5, but we want from 4 to 8, so from here to there is all we want. So we'll erase this, -5 from 4 to 8, right there. At 4 we've got the equal symbol, so a closed circle. At 8 we don't have the equal symbol, so it's an open circle. 13, same type of problem. F of x equals 3x minus 1. So what's our y-intercept is negative 1. What's our slope? Up 3 over 1. Up 3 over 1. Up 3 over 1. Down 3 left 1. Down 3 left 1. Down 3 left 1. But our constraint says we just want x values that are what? Less than or equal to 2. So 2 is right there, right? So that's this point here. So I've got the equals to, so I'm going to go a closed circle here. That's a little big. Let's make that a little bit smaller. There. And less than goes to the left. So I'm going to continue this to the left. What do I do at this point? I don't want that point. That's greater than 2. So I'll erase it. I don't want that point. So that means my next one, right, is going to be x values greater than 2, everything this side. So let's do that. That's f of x equals 4, right? So 4 would be, you know, this horizontal line, right? But we just want on the right side of 2, greater than 2. So continue that out. At 2, we don't have the equal sign, so I'm going to use an open circle. I don't want everything else on that side. And that's our graph. Uh-huh. 14. F of x equals 2/3 x minus 4, so minus 4. 2/3 would be up 2, right 3, up 2, right 3, up 2, right 3, up 2, right 3, down 2, left 3, down 2, left 3, down 2, left 3. But our constraint says we want x values that are less than -1, so where's -1? -1 is right here, right? So this is a tiny bit tricky. I'm just gonna freehand this, you know, because we're at -1 here, less than, so imagine a straight line going through here, right? So where would -1 be? In between those 2 points somewhere, you know, right here. So open circle, because we don't have the equal symbol. At -1, we'll continue those points. I'm going to erase all those points that are greater than -1. Same thing here. F of x equals -5 halves x plus 6. What's our y-intercept? Is it 6? Right? And then we're going to go down 5, right 2. So down 5, right 2. Down 5, right 2. Down 5, right 2. Okay, and here we just want x values that are greater than or equal to -1. So if we were to continue this to -1, you know, well, if we're going down 5, right 2, then if we're just going to left 1, that would be up half of 5, right? Because 1 is half of 2. So half of 5 would be 2.5. So this should be, actually, we could figure that out exactly. That's right here at 8.5, right? So we've got the equal to symbol, so closed circle here. And we'll just continue that out. And there's that graph. Now, 15. Graph this and its inverse, so f of x equals 3x minus 3. Well, what's our y-intercept? Would be -3. What's our slope? Up 3 over 1. Up 3 over 1, up 3 over 1, up 3 over 1. Down 3, left 1. Down 3, left 1. Alright, so that's this, and then its inverse. Well, probably the easiest way would just be to change the coordinates of these points. This point right here is 1, 0. So what's its inverse? Would be 0, 1. Right there. This point here is 2, 3. So what's its inverse? 3, 2. This point here is 3, 6, so its inverse would be 6, 3. I messed up somewhere. How did I mess up? Let's see here. This first point is 1, 0, so it's 0, 1. Next point is 2, 3, so it's 3, 2. 3, 2. That's why 3, 2 is right there. There we go. And then the next point is 3, 6, so that's 6, 3. And our last point would be 4, 9, so that's 9, 4. 9, 4 right there. And then as we move this way, we're at 0, negative 3, so that's negative 3, 0. And what do we notice? This slope is up 3 over 1. This slope is up 1 over 3. Right? So we could just continue on with that. Right? And there's that equation. So now what's this, or that's that graph. What's this equation? This would be y equals, what's our y-intercept? It would be 1, so plus 1. What's our slope? Up 1, right 3, so 1/3 x plus 1. Same thing here. Our equation has a y-intercept of 4. Y-intercept of 4, and then we're going to move up 2, right 3. Up 2, right 3. Down 2, left 3. Down 2, left 3. Down 2, left 3. And now let's do our inverse points. Right? This point here is 0, 4, so its inverse would be 4, 0. This point here is 3, 6, so its inverse would be 6, 3. This point here is 6, 8, so its inverse would be 8, 6. Moving this way, this is negative 3, 2, so it would be 2, negative 3, 2, negative 3. And we can see what's the slope now. We're going up 3, right 2, right? Up 3, right 2. So down 3, left 2. Down 3, left 2. And here's this line. And what can we see? Well, we've got a y-intercept of negative 6, so that's minus 6. And we're going up 3, right 2, so 3 halves x minus 6. Solve for the algebraic inverse of each one of these. So this is, all these are the same as y equals, right? So I'm just going to do that for the first one. So this is y equals x plus 5, which is the same as x equals y plus 5, subtract 5, and we've got y equals x minus 5. That would be its inverse, which can also be written as y equals x minus 5. Right? Okay. So here we'd have y equals 3x minus 3, or x equals 3y minus 3, add 3, x plus 3 equals 3y, divide by 3, and we get y equals 1/3 x plus 1. We rewrite it, y equals 1/3 x plus 1. This one, y equals 1/2 x minus 5. So that would be x equals 1/2 y minus 5. We'd add 5. X plus 5 equals 1/2 y. What's going to undo multiplying by 1/2? Multiplying by 2. So that makes 2x plus 10 equals y. Y equals 2x plus 10. this one, y equals 2/3 x plus 4, which is the same as x equals 2/3 x plus 4. Sorry, I don't mean to be saying the same. The inverse, how our first step is to flip-flop our x and y. Alright, so this is x equals 2/3 y plus 4. So we subtract 4, x minus 4 equals 2/3 y. What's going to undo that? Multiplying by the reciprocal by 3/2, multiplying by 3/2, and so we get y equals 3/2 x minus, and 2 and 4, right? So that's a 2, that's a -2, -2 times 3 makes -6. So y equals 3/2 x minus 6. 21, y equals -3/4 x minus 6, so that's x equals -3/4 y minus 6. We'll add 6, x plus 6 equals -3/4 y. What's going to undo that? Multiplying by -4/3, so y equals -4/3 x, 3 and 6, the 6 turns into a 2, right? And 2 times -4 makes -8. So y equals -3/4 x minus 8. Y equals -5/2 x plus 2. We'll rewrite that as x equals -5/2 x, y plus 2. Subtract 2. X minus 2 equals -5/2 y. What's going to undo that? Multiplying by -2/5, multiplying by -2/5, and so we get -2/5 x. -2 and -2 make +4, so plus 4/5 equals y, and that's kind of a messy one. This is y equals 2x minus 5/3. We'll rewrite it as x equals 2y minus 5/3. To solve this for y, our first step is going to be to multiply by 3. To simplify, we get 3x equals 2y minus 5. Add 5, 3x plus 5 equals 2y. Divide by 2, and so y equals 3/2 x plus 5/2. And our last one, y equals -3x minus 4 divided by 5. That's the same as x equals -3y minus 4 divided by 5. I keep on saying the same as. I don't mean to. Just our first step is to exchange x and y, not the same as. So now what's going to undo? Divided by 5, multiplying by 5. So we get 5x equals, our 5 simplified, that's why we did it, -3y minus 4. We'll add 4. 5x plus 4 equals -3y. Divide by -3. And so we get y equals -5/3 x and -4/3.